In this video, I will be explaining the positive clamp circuit. I have a 6-volt peak-to-peak signal, a sinusoidal signal, inputted into the circuit. The frequency is 60 Hz and the period is 16.66 milliseconds. I have a 100 microfarad capacitor in series with the parallel combination of a diode and a 100K ohm resistor. The diode I'm using is the 1N4007 diode. I will be inputting a 6-volt peak-to-peak signal, and at the output, I will also be getting a 6-volt peak-to-peak signal, but this new signal will have a DC offset. Now let me explain a little bit about how the circuit works. On the positive alternation of the input, the capacitor is charged up through the 100K ohm resistor. That charge is where you get your DC offset from. On the negative alternation, the capacitor is further charged through the diode. This is where you get this minus 0.6 volts from. This is the result of the negative half cycle being sent through the diode. This voltage right here will be the DC offset. This same voltage is the same voltage that will appear across the 100K ohm resistor. Now I'm going to find the volts DC offset. The input signal is 6 volts peak to peak. What that means is that you have a plus V peak of 3 volts, and at the bottom you have a minus VP, also 3 volts. So to find the DC offset, VDC equals minus 3 volts plus VDC equals minus 0.6 volts. Equals VDC equals minus 0.6 volts plus 3 volts. And that gives you a DC offset of 2.4 volts. Now I will find the volts RMS. Volts RMS equals the square root of 2.4 volts squared. Right here is where the DC offset occurs, of 2.4 volts squared plus the 3 volts peak squared over 2. And that will give you an RMS value of 3.20 volts. Now, the period is 16.66 milliseconds. But in order for this circuit to work properly, you need a long time constant when you multiply the capacitor and the output resistance. And the way to find the time constant, RC time constant equals the 100 microfarad capacitor times the 100 k ohm resistor. (100 microfarad times 100 k ohm). That gives you a time constant of 10 seconds. Relative to 16.66 milliseconds, that's a very long constant. This brings me to the end of the video. Share the video, share and like the video. Thanks for your attention.